Okay. Good morning, everyone. I'm Amalkarthi from Metallurgical Engineering, second year, Government College of Engineering, Salem. Okay. Today I'm going to present a seminar on the topic about the instability in necking, which come under the mechanical behavior of testing material. Okay. Let's explain the introduction of the topic named as a instability in necking. First of all, the necking is when a stretched material becomes a thinner at one smallest region before it's finally break. Let's back to the introduction. The instability in necking occurs during tensile testing when uniform plastic deformation changed into the localized deformation. What I'm trying to say that when a ductile material is subjected to the tensile stress test, it's first elongated uniformly. After reaching a maximum load, deformation becomes contracted in small region. This phenomenon is called necking, and start of necking is known as instability in tension. Okay. Okay. Next, definition of instability in necking. Instability in necking is the point at which a material begins to deform locally instead of uniformly. What I'm trying to say that the instability in necking is the condition during the tensile testing, when a material is no longer deform uniformly and start to deform locally, causing a reduction in cross-sectional area is known as a nick. The next, why stabilities occur? The instability occurs when a reduction in cross-sectional area increase stress faster than the strain hardening increase strength. Let's explain detailing. During tension, strain hardening increase strength, and also the reduction in the area increase stress, and also the instability occurs when increase in stress due to the area reduction value, uh, and also increase in strength due to the strain hardening. Okay. Next, the type of nicking. Based on split of deformation, nicking can classified into two types: diffuse nicking and localized nicking. The diffuse nicking is occurs when over a large length of specimen and also happen in first. Similar to the nicking in a cylindrical tensile specimen. And next, localized nicking is known as occurs in a narrow band, finally stage of before fracture, and also common in a sheet metalling forming. Let's show the picture about the type of necking. First of all, the diffuse necking is occurs in a large length of specimen is known as a diffuse necking, and also the occurs in a narrow band is known as a localized necking. Okay. Next, the condition of instability. The condition of instability is reached when a rate of strain hardening is equal to the true stress. First of all, the load formula is P is equal to sigma A. First, P is a load, applied load, and sigma is a stress, and the area is a area of cross section. At maximum load, the is known as a start of necking. Del dP is equal to 0. When it's applying to the load formula, first of all, the P is equal to sigma is under the differential formula. Let's dP is equal to sigma dA plus AD sigma is equal to 0. It's according to the UDV method. Next, for the plastic deformation at a constant volume, the dA divided by A is equal to minus d epsilon. It's a condition when we substitute to the above equation, its final conclusion of the formula is d sigma divided by d epsilon equal to sigma. It's a final conclusion of the condition of instability, and also that it is a condition for tensile instability is known as a necking. Next, the formula explanation. The above formula is explained that is the condition means that the material can no longer support additional load by strain hardening alone. What I'm trying to say that the rate of strain hardening is equal to the true stress. It's a graphical representation of necking criterion. It's explained the graphical interpretation of necking criterion. What I'm trying to say that is so this the specimen how to deform. The first of all, first it undergoes the elastic deformation, next the plastic deformation, and finally the goes to the fracture. The next is determine the point which maximum load is occurred. Okay, this graph is explained that the plot of true stress versus true strain. Uh, it's explained the necking point is where a slope of curve is equal to the stress value. After this point, uniform elongation stop and also the local deformation is begins. Okay, okay. What I try to say that in a graphical explanation on true stress strain curve, nicking start at a point where a slope of curve is equal to the stress value. I already told that the point is before. Okay. In before equation, where is used in other equation likewise the power formula the sigma is equal to k epsilon power n. It's what I'm trying to say that in material with high strain hardening, exponent shows more uniform elongation before necking. Okay, next the application of instability in necking. The necking analysis is used in material selection, tensile members design, and also the sheet metal forming. What I'm trying to say that it's used in designing ductile material, sheet metal forming operation. Its main point the understanding the maximum load capacity of the material. Next the conclusion of the instability in necking. The necking begins at the maximum load and marks at the start of plastic instability in ductile materials. What I'm trying to say that necking begins at the maximum load. It marks the start of plastic instability, covered chain hardening behavior, and it's important for safe mechanical design, and also marks as a start of plastic instability. Okay, this is the conclude my seminar on the instability in inking. Thank you for all to watch the video.